We should be rolling in 3, 2, 1. Hello, everybody. Thanks for sticking with us there through some technical difficulties.
Awesome. Hello, and thank you for tuning into the Fisk Planetarium's virtual Science Under the Dome talk series. My name is Jimmy Negus. I am one of the lead facilitators for the Science Under the Dome series, and I'm also a fourth-year graduate student studying astronomy at CU Boulder. As a reminder, we will continue to provide high-quality online videos until Fisk Planetarium reopens under the following categories: science and society, the science of sci-fi, and climate change in our backyard. And of course, please be sure to drop all questions in the chat section below, and we'll get to them at the Q&A at the end. Today's feature talk will be given by Erica Schreiber. She received her bachelor's degree in Earth and Atmospheric Sciences from Cornell University in 2012, with a concentration in climate science. Her master's is in geography from the University of Delaware, received in 2015, and she recently defended her PhD in geography at CU Boulder. Her PhD research focused on how storms in the Arctic impact sea ice and how climate change is affecting that relationship. She is now working at UNAVCO as a polar engineer, facilitating studies of Antarctic glaciers. Also joining us is our navigator and Fisk's very own, Jeremy.
Hey.
Excellent. So tonight's talk is all about climate change in our backyard. Fires, flooding, heat waves, droughts, extreme events in a changing climate. Erica will guide us through the link between extreme weather and climate change. Wildfires in the West have broken records and affected air quality across much of the country. In fact, there have been so many storms that the National Hurricane Center has run out of names in 2020. Has climate change actually contributed to these events? Are they becoming more frequent? Heat waves, droughts, floods, and even cold snaps. Erica will talk about the mechanisms through which these events can be influenced by climate change and what we can expect to see in the future. With that, Erica, please take it away.
Great, thanks, Jimmy. Hi, everyone. Thanks for sticking around through our delay. But yes, welcome to our Science Under the Dome series. We're not under the dome right now, but we're doing our best. So to start things off, we all know that 2020 has been quite a year, politically and also climatologically. If you take a look at this satellite imagery, this is from this past September, you can see the smoke moving across the continental US. You might also notice two tropical storms, one in the Gulf, that was Sally, and then there's one smaller one over in the Pacific as well. So, for those of you here in Colorado, the wildfires are probably what you've been thinking about most this year. This is a picture of the East Troublesome Fire, which was the second ever largest fire here in Colorado. Still isn't 100% contained as far as I'm aware. But before we talk more about these events specifically, I want to give a little primer about climate itself. First, is the climate changing? I get asked this more than you might expect. The answer is yes, absolutely. The temperatures have been going up throughout our entire recorded history, and the last 7 years have had the 7 warmest Septembers in history, this year being the warmest ever. And this is happening all across the planet. Now, why is the climate changing? Well, the reason that the Earth is even warm enough for us to live here is the greenhouse effect. So this gift started a little late, but here's the beginning. So sunlight reaches the Earth, it heats the surface. Some of it is reflected back to space, but some of it is absorbed by the surface, some of it is absorbed by the atmosphere, and the gases in the atmosphere that absorb it are the greenhouse gases, and they re-radiate it down to Earth and keep us warm, kind of like a blanket. But like I said, without any greenhouse gases, our planet would not be warm enough to live. It would actually be below freezing all of the time. But what's happening now is that Carbon dioxide, which is a greenhouse gas, and other greenhouse gases are increasing in concentration in the atmosphere. So this is a record that has been recorded by scientists since the 1950s of carbon dioxide concentration at Mauna Loa Observatory, which is in Hawaii. And you can see there's a pretty consistent increase, although you may also notice there's a bit of a wiggle up and down, and that's every year. And that's a totally natural process. What's happening there, and what you're looking at here, is that the carbon dioxide in the atmosphere is constantly being circulated, and you can see it's being emitted in particular where there are a lot of people. You can see China right now as the planet rotates, and I'll speed this up a little bit. We get to seeing Europe, we'll get to seeing the US, but if you've been keeping your eye on the dates here, we're getting into June, and now you may be noticing that these reds are not as strong. And what's happening is that as we get into summer in the Northern Hemisphere, the plants and trees start growing and they start sucking carbon dioxide out of the atmosphere. And the Northern Hemisphere has the vast majority of the land on our planet, and it has the vast majority of the plants and the trees. And so we see that annual cycle every year, up and down, up and down. But overall, over time, the concentration of carbon dioxide in the atmosphere is increasing. Now, how do we know that this is different than what's been happening in the past? Well, scientists can actually get data from ice cores. So in Antarctica, in Greenland, scientists drill down into the ice sheets and pull out these long tubes, and then we can get data from the layers of snow. And for those of you here in Colorado, you may not know, we actually store a lot of them here in the Denver area in Littleton. It's very cool. Literally very cold. When you walk into this room that you might see in this picture, the inside of your nostrils freeze immediately. But very neat. So how this works is that as snow is falling each year, each winter, in some places, maybe even in the summer, the layers accumulate and keep packing things down and down and down, and the snow eventually turns to ice. And these layers get kept for thousands and thousands of years. The Antarctic ice sheet in particular is really thick. It's almost 4 kilometers thick. And we have collected cores over 2 miles long, about 3.7 kilometers long. And that record goes back thousands of years. So looking at this graph again, with the little star where we are now, over 400, almost at 420 parts per million. Now, if we go back in time, so shrink that, move it over, you can see going back 10,000 years, and our carbon concentrations are way above what we have seen in the last 10,000 years. And actually, the deepest ice core gets us back to 800,000 years. And you can see that there is actually quite a lot of natural variability in the system, and we do understand why this happens. It's primarily due to orbital changes of the Earth going around the sun. We're not always doing the exact same thing, and basically this affects how the sunlight interacts with the surface of the planet. But what you can see from here, I'm sure, is that over the last 800,000 years, carbon dioxide concentrations were staying between about 180 and 280 parts per million. And now we are up over 400. And this is due to emissions from burning fossil fuels primarily. Now, if we want to take this climate change that we know is happening and attribute individual events like the fires we've been seeing or a flood or something, it's actually really hard. It's kind of like attributing home runs to a player on steroids. Now, a baseball player taking steroids is probably going to get a lot of home runs, but before he took steroids, he was probably getting some home runs too. And so an individual home run, you can't necessarily say, oh, that's because he took steroids. It might be due to something else, like which side of the East River he's on. But scientists are trying to understand these individual extreme events and figure out if they can be attributed to climate change. So what I have here is just a screenshot video. Let me play it for you. Of this website called Carbon Brief, where they are collecting studies looking at if all of these individual events, drought here, ecosystems, can be related to human influence on climate change. And as you can see, the pink ones are ones where human influence has been found. The blue ones, which do show up occasionally, human influence was not found. And then the gray ones are where the study was inconclusive. And you can look at these and see these specific studies if you're interested and what they found, and see that there are, in fact, a lot of events that are either more likely or happening more frequently due to climate change. Oops. And then they also give you this graph, which shows you all of the an accumulation of all the studies that they've looked at, and 69% found that the events were more severe or more likely to occur due to human influenced climate change, and that less likely is that it was less severe, or there was no influence, or they were inconclusive. So how do these specific events how can we actually relate them to the climate changing? So first, let's talk about heat waves. How do heat waves relate to climate change? So kind of a conceptual idea of this is if you take just a normal distribution of temperatures that we're measuring any given day, any given year, there's an average, there's some hot, some cold, there's some really hot and some really cold. But if you just start bumping up the average a couple degrees, you can see that the extreme heat events become much more frequent. There's way more of them. And now this is just, like I said, a conceptual model of what might be happening. But if we actually take real data, we can see that this is what's already happening. So this little animation is starting out with a normal distribution from temperatures we measured between the 1950 to 1980. And then as we move through time, you can see that those temperatures being measured are becoming, on average 1 degree more, but there's far more frequency of 3 degrees warmer, 4 degrees warmer. And, a couple degrees might not seem like a lot, but if you put it in context of days above 100 degrees, for example. Here in Colorado, we get a few of those each year, maybe, but by the end of this century, we're going to be getting maybe 50 a year. And it's not just that these events are becoming more frequent, they're also sticking around longer. Like you might have, instead of 100-degree day, where you're suffering for 24 hours and then it gets a little better, those temperatures stick around for 2, 3, 4 days. And it's really hard to recover from that when you're still stuck in it, right? Now, the consequences of those heat waves, as some of us maybe have already experienced, when the air is warmer, it's more likely to be stagnant and it kind of holds low-level pollution in. People in Denver and LA probably have experience with this with smog. If it gets too hot, it can actually damage infrastructure. Roads crack, pipes are expanding and contracting and they can crack. Hyperthermia, that's the opposite of hypothermia, which you maybe are more familiar with when you're really hot and can't cool down. Power outages, because people are using their AC so much and the grid can't handle it. Crop failure, because the plants can't handle that amount of heat. And also actually, when air gets warmer, it becomes thinner, and so there's less lift. And Denver Airport here in Colorado actually has some of the longest runways in the world, because we're at a high elevation, the air is already thinner, and you need that air to take off. And as it gets hotter, there's even less lift. And there's actually been, I don't think it's ever happened in Denver, but there have been days in Phoenix where they haven't been able to fly because it's just too hot and the planes can't take off. This is particularly a problem in cities. For example, in Denver, it can be up to 23 degrees hotter within the city than in the rural areas surrounding. And Denver actually has the third worst case of this. It's called the urban heat island effect. What's happening is that the asphalt, the concrete, it absorbs the heat and then it re-radiates it, rather than like trees and grass don't heat up as much. And so it gets a lot hotter than it would have otherwise been if you're in a city. And Denver in particular is bad because it's so sunny. We don't get a break with a cloudy day. The other two, the cities that are worse than Denver are Albuquerque and Las Vegas, which are similarly quite sprawling and very sunny. Now, from heat waves, let's go into drought, which you can probably in your mind put those together. If heat waves are associated with climate change, probably drought is as well. And I want to talk about sort of two different types of drought. There's meteorological drought, which is just less rain, it's hotter, there's more evapotranspiration, so that's water evaporating from lakes and rivers, and also plants releasing their water. And then there's also hydrologic drought, which is the stream flow, the amount of water in our reservoirs. And so those are sort of two different aspects of the same thing of drought. And now what happens is we have warmer temperatures, right? And warmer air actually holds more water. There's an increased evaporation rate. So there's more water that can get up into the air with those warmer temperatures. And so the soil where this water is coming from dries out and, you know, eventually gets blown away. There's then less input into the air and there's going to be less precipitation. That means lower stream flow, less snow and rain. And we have absolutely been seeing this already. Drought across the West has been getting worse. There's been a few really bad days, a few really bad years recently. And this graph doesn't go through 2020, but we can look at 2020, 2019 into 2020 here. And you can see all across the country, not just in the West, we're seeing dry conditions. There's some really extreme drought out here in Colorado and across much of the West. And that's really important because so many people depend on water. You know, the Colorado River Basin is very big, and even us, we're on the other side of the Continental Divide here in Boulder or Denver, but we still do use water from the Colorado River Basin. And most years, the Colorado River doesn't even actually reach the Gulf of California. This is a picture from 2014 where it just barely did, but that was the first time in 16 years that it had happened. So we are sucking the Colorado River dry, and it's struggling to replenish itself because we're having these drought conditions. And this is the same thing. Lake Mead, which is at the Hoover Dam, where we block off the Colorado River. This is 2019. You can see levels are far below what we would want them to be for all of this water that we need. And part of what's happening is that not only is it just generally dry, but we're getting less snow. So this is a graph of snow water equivalent, which is basically the amount of snow, how much water it's holding. And you can see across the West, you know, the Rocky Mountains primarily, there's a lot of it. But as we get to the end of the century, there's way less. And part of the reason that's happening is just generally drought conditions, hotter conditions, less precipitation, but also because it's warmer, precipitation is falling as rain rather than snow. Here in Colorado, historically, most of our precipitation has fallen as snow. You can see in the 50s, it was up to 80% of the water that fell that year was as snow. But now it's becoming much more likely to be rain. And the rain just keeps washing downhill and keeps going this rather than holding on to it like snow. Like I have here, there's this term, the water towers of the West. Those are our mountains. And we're losing the snow that are our water towers. So that's less water, but there's actually instances in which we get more water. So how does flooding relate to climate change? This image is from here in Boulder in 2013. For those of you that were here, there was a really awful flood, and probably even people outside of Colorado heard about it. So there's a couple different sources of flooding, and there's different aspects of climate change that are impacting that. First, there's more moisture in the atmosphere. Like I said, the warmer air results in more evaporation, and so there's more, just a total increase in the amount of moisture in the atmosphere. There's also rain, which is more likely than snow. And as you can imagine, when rain falls, it's immediately washing downhill, like I said, and that's more likely to cause a flood than snow that stays where it is and slowly melts. There's also stronger and slower moving tropical storms. For those of you on the coast, you know that hurricanes and tropical storms can lead to storm surge and flooding. And with climate change comes with global warming comes higher sea levels, and that just means the coasts are even more susceptible to flooding. So there's actually more heavy rain. So like I said, again, the atmosphere holding more water, has more water in it, and so it takes more water for it to reach its saturation point and then rain out. But once it does, there's more water to fall. And so we're getting an increase in heavy rain events in Colorado and in much of the country. There's also this really interesting phenomenon called atmospheric rivers. If you watch this animation, you can see that this is integrated water vapor. So it's the amount of water in the atmosphere in those areas. And you can see down by the equator, there's a ton of water, but you can see these tendrils that particularly reach up and hit California. And there's a ton of water that comes with those. And again, because there's going to be more water in the atmosphere, these atmospheric rivers are going to be more intense when they happen. And they are a natural part of the climate system, but they're just going to be more extreme as we move into the future. With sea level rise, higher tides, like I said, we're likely to see more flooding. And this is showing you just that. The number of floods happening yearly in the US is going up. And if you're not familiar with tropical storms and storm surge, so basically the low pressure of these storms kind of pulls the water up and can bring it inland. And if your tide is higher, and if the level of the ocean surface is higher, it's going to be able to reach further inland. And we are already measuring substantial sea level rise. The ocean surface is going up about 3 millimeters per year. And that's due to two different things, both the ice melting. So Greenland, Antarctica, mountain glaciers are melting and their water is going into the ocean. And also the thermal expansion of the ocean. So the water of all the oceans is getting warmer, and that means it expands. And that accounts for about half of the sea level rise we're seeing. And additionally, there's the intensity of hurricanes. So hurricanes form over warm water, and the warmer the sea surface temperatures, the stronger those storms are likely to be. And if you look at this graph, you see what we're currently seeing, the distribution of intense tropical storms, hurricanes in this case, category 4, category 5, and what we expect over the late 21st century. And this probably looks like what I showed earlier to you, just this movement of the distribution of these events. The frequency of hurricanes is a little more complicated. Speaking of 2020, we, as Jimmy mentioned, we have had more hurricanes this year, more tropical storms than ever recorded. We just had Hurricane Iota slam into Nicaragua the other day. The only other time we've run out of names in the Atlantic and had to move into Greek letters was in 2005. That was the year of Hurricane Katrina. That was a very active year as well. And so from this, you might be like, oh, wow, hurricanes are getting more frequent. That's a little bit more difficult to say than that they're getting stronger, in part because our records of hurricanes don't go back as far. As if you look at this map, a lot of the hurricanes never hit the coast. And back before we had satellite data, we didn't know about the hurricanes out here in the ocean unless a ship happened into it. And if a ship did happen into it, that ship maybe didn't even survive. And so understanding If the frequency of storms is increasing, is a little difficult, but the strength of them is absolutely going up. There's a few risk factors also that flooding might be related to besides just climate change. One is just generally increased development of our cities. So if you remember Hurricane Harvey that hit Houston, the flooding there was incredibly terrible. And that was in part because Houston is so sprawling and has so much impermeable land. That's the asphalt, the concrete there. The water can't go into the soil. And so it just stays above the ground level. And that is hurting, that is causing flooding to be even worse than it might have been in the past. Also just generally unmaintained infrastructure, that's a problem across the country and causes a lot of different issues. There's also, of course, loss of life and property, and also the pollution of our water resources that occur because this water is getting in places it wasn't supposed to and then running downhill, running into our rivers. Do not drink flood water. Stay out of it. I promise. Bam. Oh, and I missed a bullet there. Generally, also poor floodplain management. So people are building houses and other buildings in areas that we know are floodplains, New Orleans, for example. And as we get stronger storms with higher sea level, more flooding, this is just going to become a bigger problem if we don't also address those risk factors aside from climate change as it is. Now, I know most of you here probably, like we said at the beginning, are thinking about wildfires. So we did heat waves, we did drought, and now, sort of a finale, we have wildfires. How do they relate to climate change? And now, first, I wanted to just start out with saying wildfires are a natural part of the climate system. They're happening all over the world, all the time, seasonally. And the issue that we're having is that they're getting worse, primarily. And as you can see, the American West is not even where our worst fires are, although this series is climate change in our backyard. So we're mostly talking about what is happening here in the US and particularly here in Colorado, where I am at least. So first, climate change is making temperatures rise. We know that. It's getting warmer. So the snow is melting sooner. That means we don't have that water source later into the season. And the later we get into the summer, the worse the wildfire conditions generally are. Also, like I said earlier, we're getting less snow, which is obviously also contributing to that problem. And generally, the landscape is drier. And so wildfires can just spread extremely quickly when the trees are dried out and all the plant life is dried out and everything can just go up just like that. There's a lot of things that are risk factors for wildfires. And one of them being low humidity. So like I said, as the air gets warmer, it can hold more water. And so if the same amount of water is in the atmosphere than there was earlier, that's a lower relative humidity. There's also the dry fuel, which we just mentioned, the buildup of fuel from fire suppression in the past. So historically, we have tried to prevent any fires from happening at all. And that just means there's all this more grass building up, trees building up, plant life building up, that's just ready to burn when that fire does finally happen. And we are learning from that, and we have prescribed burns now. And sometimes when a fire starts naturally, it's decided if people or property at risk, they'll let it burn for a while just to let that natural process happen. Also, high winds result in worse fires. The topography, if a fire starts at the bottom of a mountain, it can climb up it much easier than it would be able to climb down. Increased human development as well. People are, in part because of the housing crisis, are building more into wildfire areas. Also, just the existence of people means more likely for purposeful fires, campfires, burning trash, but also accidental fires like sparks from electricity or someone dropping a cigarette or what have you. There's also beetle kill, which is often brought up. There's problems with beetles killing our pine trees out here in the West, and it's kind of I don't want to say controversial, but there's not as clear of a relationship as you might expect. You might think that, oh, beetles have killed this tree, now it's more likely to burn. But my understanding is that actually after a few years, because all of the needles will fall from that pine tree, it's actually harder for fire to move through that area because there isn't actually as much ability for the fire to jump between branches and between different trees. And then you probably notice the graphic I have up here. It is projected that there's going to be more and more time with risk of fires, even outside of the West, as we get through to the mid-century. And just there's, looking back in time, the amount of land that has been burning each year is generally increasing. So you can see in this graphic, there are tons of fires every year all over the place. But you may notice that these red ones, over 5,000 acres, are what are really showing up more and more. And I added a few data points here at the end because this graphic only goes through 2014, but you can see that those numbers have continued to be high. This 2020 number that I got maybe a week ago is probably not even up to date anymore because there's still a few fires burning, and we can't get that number for sure until December 31st. Looking a little more closely at the 2020 fires in Colorado, I showed you earlier some satellite imagery. This smoke plume here is the Cameron Peak fire, and there's also a little bit of smoke coming from here, the Pine Gulch fire out by Grand Junction. That was the biggest fire ever recorded in Colorado until the Cameron Peak fire started, and then that became the biggest fire ever recorded in Colorado. And then, so that's looking at this map to show you the actual areas of those fires. So we have the Pine Gulch fire, the Cameron Peak fire, and East Troublesome fire, which is the image I showed you at the beginning. These are the three biggest fires ever in Colorado history, and they all happened this year. The East Troublesome fire has not overtaken the Cameron Peak fire, but I don't think either of them are 100% contained yet, so we'll get those final numbers eventually. But the Cameron Peak fire is now over 200,000 acres alone. Both the East Troublesome fire and the Pine Gulch fire are over 100,000 acres themselves, and I think there's only been 3 other fires ever recorded in Colorado that were above 100,000 acres themselves. So this year has, as I showed earlier, been a drought year, and we've seen the consequences of that. There's been the poor air quality. This is a graphic of smoke. I haven't mentioned California, but California has arguably had worse fires than we've even had here in Colorado, and this smoke has gone across the entire country. I think those of you on the East Coast even had some hazy days. This is a picture of San Francisco, as you can probably tell. That's the middle of the day. The smoke was so bad. So there's the poor air quality. Many of us have had to stay inside, aside from COVID, also not even going in our own backyards. There's the displacement of people who are running from the fires, also animals are running from the fires. There's been increased bear sightings, for example, in Fort Collins, Colorado, as those animals are also trying to get away from the fires. There's loss of life and property that happens with all of these. And there's also an increased risk of erosion. For example, the fires in Santa Barbara, California, a couple years ago, there was a huge mudslide afterwards. The rain came too late, and all of those trees that burnt were no longer holding the soil in place. And so they had a huge mudslide. And that is likely to continue to happen. So now to kind of step back a little bit, I talked about these 4 events that were in my title. There's of course more. if you look at that website, by the way, I showed earlier in that little video, there's a link in the video description, as well as some other interesting links about climate change and extreme events. But we know the Earth is warming. I showed this picture early on in the presentation, but what you may have noticed is actually the Arctic is overall warmer than most of the rest of the planet. And like Jimmy told you, I've been studying the Arctic. I've been talking now about what's happening in Colorado mostly, but you couldn't get away without a little bit of Arctic science. So what is happening in the Arctic that it's warming even more than most of the rest of the planet? There's one process that is primarily the cause of this. It's called the sea ice albedo feedback. Albedo is just the reflectivity of a surface. So sea ice is white. It's very reflective. So sunlight, when the sun comes up in the summer, it's just bouncing right off the ice in the Arctic. But, you know, the globe is starting to warm. There's a little bit less ice. It's melting away faster. Now the energy coming from the sun is being absorbed by the ocean. The ocean is much darker than the sea ice. And so the ocean is, rather than reflecting, it's absorbing this energy and it's getting warmer, and it will melt the ice even more. And then more of the ocean will be exposed and it will warm up and it will melt the ice even more, et cetera, et cetera. This is called a positive feedback loop. And that is, we are currently observing that in the Arctic. Now, why is this maybe important to us that the Arctic is warming, if we're just talking about climate change in our backyard? Well, the entire planet is connected. So this is winds. I showed a similar image of a video earlier of the globe. This is from NOAA's Science on a Sphere. So if you've been to Fisk Planetarium, or if you've been, for example, to the Denver Museum of Nature and Science, they have a big 6-foot globe that they project this data onto. We can't look at that in person right now, but they do have a website that you can look at this data yourself. There's also an app that I think might be able to do some sort of like virtual 3D something. But anyway, this is showing you winds across the planet. And you may notice these areas of much faster wind in red in both the northern and southern hemisphere. These are jet streams. You've probably heard of the jet stream before. What the jet stream basically does is it separates this warmer air from cooler air. So the warmer air has, at the lower latitudes, there's higher pressure there and it's separated from the lower pressure at the poles. You may have heard the term polar vortex. That's just what this is. The polar vortex is normal. It's always there. Sometimes it just comes a little south and then it's in the news. So with this warming air, the gradient between the pole and the equator is decreasing, and that's what's driving the jet stream. And so this is something that's pretty new in science, and there's some controversy with it, but I think it's fascinating, and I wanted to tell you guys about it. Basically, with this temperature gradient decreasing, the wind speeds of the jet stream are decreasing as well. And so what happens when the winds, the speed of the jet stream goes down, it actually might be becoming more wiggly. And so, like I said, the jet stream is what's separating the warmer air to the south from the cooler air to the north. And so if it's more wiggly, we get these dips and these ridges where colder air comes further south. That's when it's in the news. The polar vortex is here. But also warmer air is able to get much further north. And maybe you've seen in the news, like Greenland breaking temperature records, Svalbard breaking temperature records. This can contribute to that. Besides just these intrusions of warmer or colder air, also just the fact that the jet stream is moving slower slows down how weather systems move across the country. And here in Colorado, weather's a little more complicated because of the Rocky Mountains causing a lot of turbulence in the atmosphere. But I grew up on the East Coast, on Long Island, And if you want to know, if you're on Long Island, you want to know what the weather's going to be like tomorrow, you just look at what the weather is today in Ohio. And so with these general push of weather events across the country slowing down, then something like a really, really hot air mass, a really cold air mass, a wet or a dry one are going to stick around longer. And that contributes to all of the things I've talked about, to heat waves, to floods. The 2013 Boulder flood, for example, was caused by a weather system that just sat where it was and just dropped all of its rain. And so this is something, like I said, is some scientists say we're already observing it, some say we're not, but it's something to keep in mind that may or may not be happening and is contributing to all of these. So as my little friend polar bear behind me that I hope you guys can see will tell you, care about the Arctic too. But I don't want you to come out of this feeling depressed and overwhelmed. I threw so much information at you, and I know that. But there are things we can do. And there's, of course, use the good light bulbs, take shorter showers, all of that. And that's all great. Please do all of those things. But this is a huge issue, and it's bigger than any individual actions we can take. So what I'm going to ask from you guys is talk to your friends, your family, your colleagues. We all have Zoom Thanksgivings coming up. Talk to everyone. A lot of people have questions they don't understand, they may not realize, or they may be scared, and tell them not to be very scared. Also, advocate to representatives and to corporations. I like to tell people, definitely go out and vote, but election day has already passed. Do that in the future, but call your reps, call everyone that you can. Also, join a group that's already doing advocacy work. There's tons of them out there. Just in Colorado, we have POW, Protect Our Winter, 350 Colorado. 350 refers to the concentration of carbon dioxide in the atmosphere. This group wants to get us back down below 350. Like I told you, we're up to almost 420. Sierra Club, Citizens Climate Lobby. Of course, also support science education, like here at this Planetarium. But also, be realistic, prepare, have a go bag for emergencies. Probably a lot of people here in Colorado did that when the wildfires seemed like they were getting close. I know I did. There's a website, ready.gov, that can give you information on getting that together and making a plan. Find out specifically what your community is vulnerable to. So I think we probably have people watching from not just, the Boulder bubble, and different events are likely to affect different places differently. So be aware of what kind of climate changes you might expect to see in your community, what you can do to prepare yourself, and also talk to community members, what maybe your city should do to prepare. Just consider where you're living, what your insurance options are. If you don't have flood insurance, I recommend getting it if you can. Some insurance companies are not willing to insure people on floodplains or people in areas that are likely to get wildfires. So, keep that in mind when you're deciding where you're living, deciding where you might want to move in the future. And then, last of all, if you have any questions that I can't get to tonight, if you have someone who's giving you a hard time about climate change, send them my way. My Twitter account is SciShribes. I love to chat with people, and let's do that now. I'll take any questions you guys have. Thank you so much.
Awesome. Thank you so much, Erica, for a great talk. So I had a question personally. Yep. While folks in the chat get their ideas together, if we stopped everything now, is there anything that could go back to normal?
So most things would take time. A lot of stuff in the climate is a slow moving system. But one thing that near and dear to my heart that will, I think, rebound pretty quickly is actually the Arctic sea ice, because sea ice still freezes in the winter, and we get lots of sea ice in the winter, and we just need it to not melt so much in the summer, and it'll stick around, and everything up there will be much better for our polar bear friends.
Awesome, awesome. Cool. We also have a question. This is from Veronica. I live in Ellison City, Maryland. We had 2,000-year floods in 2 years because of what they said was storms training. Are these atmospheric rivers what caused that?
I would have to look
Okay.
specifically at what the atmosphere was doing. I don't know that term, storms training, but that could definitely be it. It might also have been a system that, just like the one I talked about in Boulder, just didn't move. But I'd be happy to look into that, Ronnie, and let you know what I find.
Awesome. It sounds like so much isn't.
That's a great question. So the North Atlantic is actually really important. I don't think I have any images that I could show this quickly, but so there's a ton of melt coming off of Greenland, and the North Atlantic is actually one of the saltiest part of the global oceans. And the very salty, very cold water sinks, and that's actually what it's referred to as a conveyor belt. And the water sinking in the North Atlantic is actually what is pulling warmer water up from the south. And many of you have probably heard the term the Gulf Stream. So this is this warm water that's moving up from the equatorial Atlantic, like near the Caribbean, up towards Europe. And it's actually the main reason why for the UK doesn't get a lot of snow. It gets rain, even though London is much further north than New York, for example. But as Greenland is melting and inputting this fresh water into the North Atlantic, that salinity is going down. And so the density of that water is going down. And so it's not sinking as fast. And so it's not pulling that heat up from the south as fast. And that's likely to have pretty substantial impacts on Europe, particularly. This is actually kind of the plot of The Day After Tomorrow, only that happened in like 3 days, and this is going to happen over a pretty long period of time. But yeah, salinity is absolutely being impacted by, mostly by melting of our ice caps.
Awesome, awesome. Well, not awesome. That's actually very concerning. But you mentioned timescales, and on that note, Natalie had a question about the future, about future children, future grandchildren. What sort of world are we leaving behind for them? And so I guess I'm also curious to know, is there any process that's occurring at a more accelerated rate? Is there a top concern among the many that you've listed in today's talk? I know it's all interconnected, but
yeah. I think probably what we're going to be seeing as an issue it's all connected. I was going to say the drought conditions that we're seeing is really stressing our water resources, but that also contributes to worse fires. And so I think that's probably what we're really going to start seeing. There's of course, and I didn't talk about this at all. There are a lot of technologies out there that we're not really using because we haven't been forced to use it yet, because everything in our country moves very slowly, and that's in part by design and in part, sometimes good. But things like what I expect to see are things like desalination. Like there's so much water on our planet. Most of it's just full of salt. And what little fresh water we have is mostly frozen. and then what's left is quite limited. So I'm expecting, I'm pretty hopeful that a lot of the things we're going to start seeing, we will find at least Band-Aid solutions to. There are, though, I mean, we live in a country that's quite lucky in that we're pretty economically successful and we can make things happen if we really need to and we work together. But there's a lot of countries that are not so well off. Particularly, there's areas at very low sea level, island nations, places like Bangladesh, and some countries in Africa where it's already really hot. And South Africa has, for example, they call it day zero, or basically the day of the year where they run out of water. And if they don't, find a Band-Aid solution. And that's definitely an issue going forward. There's already some people who can be considered climate migrants. For the Department of Defense is already paying attention to this and seeing climate change as a likely destabilizer of some countries. And so, there are a lot of things that I'd say are a little scary going into the future. But like I said, with my little positive slide here at the end, there is a lot that we can do. There is a lot that's already happening. There's a lot of groups that are trying really hard. There's even like pretty simple, like I mentioned, like advocate to corporations. Corporations have the money, have the power. Talking to or getting a group together to talk to your energy utility to say, we will pay you, a little more money if you can get us wind power instead of from a coal plant or something, and things like that. That's happening out here with Excel, for sure. And things like getting your university to divest from fossil fuel companies. We invest in the good technology, but also divest from the bad technology.
Well, it sounds like it's just a matter of time before these issues, we'll be forced to confront them, and we won't have the luxury of debating if they're real or not, because the symptoms, the effects will be so real for us. Which leads me to another question. On an individual level, there's only so much we can do. Do you advocate for the day-to-day, less showers, less driving of cars? How do you balance that effort versus, the corporate, big business advocacy? Do you think one is more pressing than the other, or do they need to necessarily work hand in hand?
I think individual actions are very important. I practice them as much as I can in my day-to-day life, but there's also, you need to be realistic. Like, I know, it would be better for me to take the bus to work, when I'm going to work. But sometimes, a time crunch just really doesn't allow for that. And it's not worth getting down on yourself if you, drove more than maybe you should have, or flew more maybe than you should have. I think, if everyone in the world got together, particularly in rich nations, where we burn a lot more energy and pollute a lot more, that absolutely would make a big difference. But the corporations and the policymakers that in some ways can control the big companies are really where, some massive changes can happen that we should absolutely be advocating for.
Awesome. Thank you so much. And I think we have one more question from Amanda. Sure. Why do fires go up the mountain easier versus down the mountain?
Yeah. If you think about, a campfire, if you're like sitting, or, if you have a fireplace in your house, fire burns up, like the flames are moving upward. They don't, like if you have a grate, for example, in your fireplace, you can see, like as your fire gets bigger, it's growing up. It doesn't move down because it's burning oxygen. And heat rises, and that's just exactly what's happening in nature. If a fire starts at the bottom of a mountain and it's burning this one tree, well, it's burning up the tree, and then it's going to find the next tree that's a little higher much easier than it might find a tree that's a little lower. And so I've been paying attention a lot to the fires that have been happening this year, of course, and what the firefighters have been up to and how they're trying to control things. And I learned this and had never realized it before, that like they take that into account. Absolutely. It's also harder to fight a fire on a steep slope, of course. But that makes a difference in how they plan their efforts and everything, and because they like try to expect and plan what the fire is going to do and everything. But it's just as simple as, heat rises, and that's where the fire's going.
Awesome. Thank you so much. Well, Erica, do you have a takeaway message for the audience this evening?
Don't give up. Also, science is really cool, and learn as much as you can, understand as much as you can. Because I think that understanding the problems that we face is the only way we're really going to be able to deal with them in any effective kind of way. So, keep learning, keep doing, and thanks for listening on a Thursday night while we're all, trapped in our Zoom bubbles.
Well, thank you all so much, Jeremy, Erica, from myself as well. Thank you for your time this evening.
Yeah, thank you so much, everybody.
Bye, everyone.
All right.